The world of quantum mechanics is a strange and counterintuitive place. It challenges our everyday experiences and forces us to reconsider the nature of reality itself. In the quantum realm, particles exist in a blurry haze of probabilities, defying the predictable laws of classical physics. This is the realm where Niels Bohr, one of the founding fathers of quantum mechanics, made his mark. Bohr's journey into the heart of the atom began in the early 20th century. At the time, physicists were grappling with the bizarre behavior of light and matter at the atomic level. The prevailing classical theories crumbled when applied to the subatomic realm. Bohr's revolutionary model of the atom depicted electrons orbiting the nucleus in discrete energy levels, laying the foundation for quantum mechanics. Niels Bohr, a Danish physicist, emerged as a leading figure in the development of quantum mechanics. Born in Copenhagen in 1885, Bohr's intellectual curiosity led him to pursue a career in physics. His early work on the structure of the atom, culminating in the Bohr model, earned him the Nobel Prize in Physics in 1922. Bohr's contributions extended far beyond his atomic model. He engaged in lively debates with other prominent physicists, including Albert Einstein, about the interpretation of quantum theory. These debates shaped the Copenhagen interpretation, a framework for understanding quantum mechanics that remains influential to this day. Central to Bohr's thinking was the concept of complementarity, proposing that certain properties of quantum systems could not be measured simultaneously with perfect accuracy. Bohr's legacy lies in his scientific contributions and his profound philosophical insights into the nature of reality. The Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s, emerged as a dominant framework for understanding quantum mechanics. At the heart of the Copenhagen interpretation lies the concept of superposition. In the quantum realm, particles do not exist in definite states until they are measured. Instead, they exist in a superposition of states, a blurry haze of possibilities. It is only upon measurement that the wave function collapses, and the particle chooses a definite state. This collapse introduces an inherent randomness into the quantum world. Unlike classical physics, where the future unfolds predictably, quantum mechanics introduces an element of chance. The Copenhagen interpretation raised profound questions about the nature of reality and the role of the observer. The double-slit experiment, a cornerstone of quantum mechanics, beautifully illustrates the wave-particle duality of matter and the profound implications of the observer effect. Imagine shining a beam of light through two narrow slits onto a screen behind. Classical physics predicts that two bright bands of light will appear on the screen. However, the double-slit experiment reveals a far more intriguing pattern. Instead of two distinct bands, a series of alternating bright and dark bands, known as an interference pattern, emerges. This pattern suggests that light behaves like a wave, interfering with itself. The strangeness intensifies when we send single photons through the slits one at a time. Astonishingly, the interference pattern persists, implying that each photon somehow interacts with both slits simultaneously. The act of observation destroys the interference pattern, forcing the photon to choose a definite path. The observer effect introduces the unsettling possibility that consciousness plays a role in shaping reality. This effect, demonstrated in experiments like the double-slit experiment, highlights the intimate relationship between the observer and the observed in the quantum realm. At the heart of the observer effect lies the collapse of the wave function. When a measurement is performed on a quantum system, its wave function collapses into a single definite state. The question of whether consciousness is necessary for this collapse has fueled debate for decades. Eugene Wigner proposed that consciousness might be essential for the quantum measurement process. He argued that the act of observation by a conscious observer collapses the wave function, suggesting a profound link between consciousness and the physical world. This idea resonates with ancient spiritual traditions that emphasize the interconnectedness of consciousness and reality. Quantum entanglement reveals the interconnectedness of the universe at its most fundamental level. This phenomenon, described as spooky action at a distance by Albert Einstein, demonstrates that particles can be linked in such a way that they share a fate, even when separated by vast distances. Imagine two particles, entangled at their creation, flying off in opposite directions. These particles, though physically separated, remain connected in a mysterious way. Measuring the state of one particle instantaneously determines the state of the other, regardless of the distance between them. This instantaneous correlation has been experimentally confirmed countless times. It suggests that the entangled particles are part of a single interconnected system transcending our classical notions of space and time. Quantum entanglement has the potential to revolutionize fields like computing, cryptography, and teleportation. The discoveries of quantum physics have sparked a renewed interest in the relationship between consciousness and the physical world. While classical physics viewed consciousness as a mere byproduct of material processes, quantum mechanics offers a more nuanced perspective. The idea that consciousness could be a fundamental aspect of reality is not new. Ancient spiritual traditions have long emphasized the interconnectedness of consciousness and the cosmos. These traditions often view consciousness as the ground of being, the fundamental reality from which all phenomena arise. Quantum physics provides a scientific framework that resonates with these ancient spiritual insights. If consciousness is essential for the collapse of the wave function, it suggests that consciousness is an active participant in shaping the universe. This emerging perspective offers a profound new understanding of our place in the cosmos. The observer effect has profound practical implications for how we live our lives. If our observations shape reality, we have a responsibility to become conscious creators of our experiences. One area where the observer effect has direct relevance is personal growth and transformation. If our thoughts and beliefs influence our reality, then by shifting our perspectives, we can create positive changes in our lives. This principle is at the heart of practices like mindfulness and meditation. By cultivating a more mindful awareness, we can observe our limiting beliefs and create space for more empowering perspectives. The observer effect also has implications for healing and well-being. The placebo effect is a powerful example of the mind-body connection. By cultivating positive expectations and beliefs about our health, we can support our body's natural healing abilities.